Hello and welcome back to the lecture of time series econometrics. In this lecture, we are going to introduce a new concept called partial autocorrelation function. And we will try to understand why we need this function in case of identifying if a series is AR or a MA series. Now, we have used ACF, autocorrelation function, in identifying AR and MA series, and we could use ACF in doing that because the AR or MA series behave, or the ACF for AR and MA series look different, right? And we are just going to see how the ACF of AR and MA series are different. We have covered it previously, but we'll talk about it briefly here. So let me write down ACF for ACF for AR series. Okay, let us write ARP series, and we'll write ACF for MAQ series. ACF for MAQ series. Okay. Now, how these two series look like, we have seen in case of ARP series, we have seen ACF would gradually die down. It never cuts off. So we'll draw it like this. It is like this, right? So it's like gradually dying down, dying down, and never cuts off. Okay. Here, the shape of the ACF plot would be the same, the similar shape we will see irrespective of whether it is a AR1, AR2, or any order, higher order AR process. Okay, so the plot would remain, the nature of the plot, the shape of the curves will remain same, irrespective of whatever order of AR you are plotting, and whether the values of ACF will be positive or negative, that will depend on whether your phi greater than 0 or not, right? Now, in the case of MA series, we have seen something different, and that is what actually helps us to identify if it is an AR series or MA series, right? So, what is different here? Say, for example, you take MA1 series, okay? If you take MA1 series, so what we see is you can get only value if you estimate the ACF, you will get value only for the first period, right? For MA1 series, or if it is a MA2 series, then you can get value of ACF only up to 2 lags. Okay, so generalizing the result, we can say you can get value of the ACF for MAQ series as long as your lag is less than equal to Q, right? So as long as your lag is less than equal to Q, you get the value of ACF in MAQ series. Now the question here is, why do we see such differences? And we'll briefly explain that the differences in the nature of ARP series, the ACF plot for ARP series and the ACF plot for MAQ series. Now, if I actually write down a very basic equation, we'll go to just simply write a AR1 series. We can write AR2 series, AR3 series, but only thing is that will make things a little complex. But nonetheless, we can write it. So that is my ARP series, right? Now we know if we expand it, if we substitute the value of yt minus 1, we'll get something like, actually I don't need to write phi 1, but let's write phi 1, no problem with that. Yt minus 2 and et and things like that. Now what happens here is my yt minus 1, like here I don't have, in the first equation I don't have any yt minus 2, right? But in the second equation, I can see that I can express my yt minus 1 in terms of yt minus 2. So we have seen that. So here it comes, and it actually influences this one here, this yt minus 1 here, and that influences my yt. So in a way, my yt minus 2 is indirectly influencing my yt here. Okay, so this is a very important term, indirectly or directly. We're just going to see that. Indirect influence, let us say. Indirect and direct influence. Okay. So that way we have lots of indirect influence. You can here get a yt minus 3, and here you can get a yt minus 2. This again is influencing, and that yt minus 2 is influencing there, right? So that way there is a whole chain of influences that goes on in AR series, okay, of any order basically. So in that case, you will see something like this exponential decay because all the past period values are influencing one way or the other. But whereas in the case of MA series, what we see is, let me write it down, MA series, okay, let me write here AR series. I have actually written AR. Whereas in the case of MA series, we will see that my YT is just an outcome of my past period ET minus 1 value. Okay. Now, when I am actually constructing my MA series, I'm just using the error term that I get from the past period, right? So I'm not really bothered about the absolute terms of YT, past period Y values. And theoretically speaking, as long as I'm just getting the error terms from the past period values, not the absolute values of the past period, so there is no way that my previous period values are influencing my YT, because I'm only constructing from the error terms, and error terms are independent. They are not dependent on anything. Okay. So that is the thing, that is the reason why I see a MA series the way I see it, right? Now, if I take a MA series of lag 2, say my equation would be something like this: YT equal to, say, I'll use theta 1, ET minus 1 plus theta 2, ET minus 2 plus ET. Okay. Now what is happening here? Or E is exponential. I mean, I'm just using these terms, interchangeably. So let's not confuse. So here, what will happen is I have, these two past period values, and there are my YT is related to both the periods, right? So both ET minus 1 and ET minus 2 is influencing, and that is why I have value till here, So I have value till lag uh, uh, 2 basically. And if I had like, higher order lags, so I would have like my MA2 series would have been extended. Here my MA2 series, this one would have been extended, right? So that is the basis of saying lag. As long as my lag is less than equal to Q, my MA series, the we will get some value for the ACA for MAQ series. Okay. Now that's about the difference of ACA between ARP and MAQ series. Now, if we have actually a MAQ series and Q is very, very high, let's say Q is, say, much higher than 2, for example. So my MA series would look like something like this. MA series would look something like this. Because now my Q is very high, right? So I have this liberty to kind of plot this MAQ series. Here it is, MAQ series. Now if I name this graph, say graph 1, graph 2, graph 3, right? So the problem, and if I compare graph 1 and graph 3, I will see there is no difference. So then AR1 series and MA of higher order series, there is no difference. Okay, so it will be difficult for us to actually identify if it is a AR1 series or if it is a MAQ series. But now here, note one point. Of course, we know the principle of invertibility when it, like we use AR1 series with respect to MA infinity series. But we'll not get into that. Suppose, let's say we are just taking order of 5 or 10, and then we will not be able to distinguish if it is a AR1 series or a MAQ series. So because of that, we actually introduce this concept of partial autocorrelation function. Now, how partial autocorrelation function would actually solve the problem? So the idea is that if we can say use a function and that can actually sort of revert the properties of the ACF plot for AR1 or for ARP and MAQ series, then looking at the reversal of the of the properties or reversal of the plot, we can be able to identify if it is a AR1 ARP series or a MAQ series. To put it differently, suppose I can convert a ARP series something like this one, this curve, okay, something like this curve. ARP series something like this curve, whereas MA1 series something like this curve. MA1 series something like this curve. So that means the properties will, it will show different kind of graph for ACF and PACF, for AR1 and for ARP and MAQ. So from that pictorial presentation, we will be able to identify if it is a AR1, ARP series or a MAQ series. So that is the idea behind using PACF.